So should we start? It's already time, yeah?
Yes, yes, I'm ready.
Okay, let me introduce Yoshinori Gongyo, who is now visiting Utah, University of Utah, and he's from University of Tokyo, and he will speak about on generalized Batyrev conjecture, so joint work with Choi. Yeah.
So I'd like to thank the organizers for giving me the opportunity to kind of the new instrument, and also so I'm very happy to become the first speaker at the Zoom Architecture Seminar. So today, so is it okay?
Yeah.
Okay. So today I want to talk about some generalization of the cone theorems. So this is the generalization of the cone theorem, and also so some other version of the cone theorem for so-called the Batyrev cone theorems. So basically, I discussed on the projective normal variety with the minor singularity, the so-called the KLT. Okay, so I'm going to start from the famous cone theorems. I just said the famous one, so many people contribute this. Okay, so famous concern for the cone, so we described the structure of the cone for the pseudo-effective curve. This is the cone of the closure of a cone of effective curves. We consider on the N1 x is this is the vector space of the one side includes the quotient by the numerical equivalence. So we consider the cone on the closure of effective curves in this finite dimensional vector space. So this famous cone theorem claims these pseudo-effective curves can be understood by decomposed by the next. Negative part. Non-negative part plus the extreme arrays. It's where so Ri is a negative extreme array according to the intersection number with Kx, and also we can claim that Ri's can span by the rational curves. And we can say more for the discount concept. So minus Kx intersection Ci is less than 2D. And moreover, we can say Ri can can be understood by the extremal contraction. This is the geometrical mean. This is the geometrical mean. So, okay, so this is the famous one. On the other hand, we have the cone theorem to describe with the other cones, so which consisting of the movable curves. So-called on the other hand. We have other constants. Or movable curves. Now this is theorem called Batyrev theorems. So this cone theorem is this cone theorem describes the similar structure theorem for the movable curve. But different. So in bar find the closure of the effective combination of the movable curves. So now I just record what is a movable. Let me just say this is movable. It's a there's some family of curves and some fiber is C. And both are irreducible. And we may assume that both are irreducible. And we require the evaluation map is dominant. Variation map C to X is dominant. Dominant. So this is what I call the C movable. So Batyrev theorem describes the NM by X. That so later I will say we cannot expect the quite same cone theorem as the NE bars for the NM bars. We need to add the some. We need to still use the NE bar X non-negative part for the KX. So we can describe the similar cone theorem, same cone theorem for the this cone. Plus some negative parts. So this is just this is great. So we can say when n bar x plus ne bar x, the negative part of the according to the kx is equal to the still the we can describe the negative part. And so we say I can be the spanned by the some curves, but I don't say the rational curves, it's the some curves. And CI intersection kx is bounded by some number. So this effective number depends on the singularity of x. I mean that this meaning just that if x has this epsilon LC, then so C should be depend on the only epsilon and dimension. And also we can say that we say that accumulation of the Ri the accumulation on the hyperplane defined by kx equals 0. So this is the so-called Batyrev concern. So Batyrev proves that this theorem for the terminal threefold. So and so Elijah proved this theorem the more but systematically, and finally, so we can I mean the Batyrev and Elijah's proof works for the by using the BAB. Now, so this is proved by conjecture. So, I mean, of course, many people working like Lemons. Before established the BAB, so we have some partial theorem for the Batyrev concern for the higher dimensions. Anyway, so by using the BAB, so this Batyrev concern is established. Okay, so in my mind, so these two concerns, I want to connect. I want to integrate these two concerns with some sense. So
интернет работает? Алеш. А? Интернет упал?
We can see that his video got frozen.
Yes. Yoshinori? Не грусти. Ой. I think it's a connection problem in Utah. Hmm. Does anyone know Yoshinori phone number and call him? Okay. Okay, Yuji will try to call Yoshinori. Just 1 second. Just a second. Okay, Yoshinori is going back, I think. Just 1 second. Yoshinori, can you hear us?
Okay, sorry. Maybe so. It's an internet connection on the university, I think.
Maybe, yeah. Because everything else was okay in the internet. Yeah, okay.
Sorry, I'm very sorry. So when I talk about motivation, so I was here there.
ゴンギョさん。
はい
そうです
はいはい
カメラにあんまり近づかないので、Please don't be, I mean,
あ
stay close to the boat.
Okay, sure.
Okay?
ちょっと
It will focus. No, Yoshinori, just stay next to the board. Yeah. It will focus at some point. Yeah. Okay.
So maybe I will start from the motivation again. So I want to I want to ask how can we understand the Batyrev concept and more concept. So I want to integrate the something that this Batyrev theorem and Morris concept. Okay, so I want to introduce some intermediate movable curves. it's a move. We say the C is movable in dimension N. There is some family of curves is again the some phi by C, and both are, I said, irreducible. So I said the evaluation of the C has dimension L. I want to describe a similar story for this movable curve, movable polynomial curve. So I will define the MML bar X is a six is movable in dimension L. Closures. So yeah, first question is the I should say the comment. First is so MN0 is
Gongyo san,
Hi.
can you hear me?
Yes, yes.
Could you write a bit bigger?
Bigger, okay, sure.
Bigger. Like the condition of CI. I mean,
Okay, sure. CI is movable in dimension less than equal to A. Can you read it?
Yeah, it's better.
yes. Hi.
Okay, sure. So I say just not is NM0 is movable. And some intermediate things is and NM D minus 1 is just the NE bar. Okay, so question is Batyrev type concern for this NML bar plus NE bar KX. Since otherwise we cannot expect the we need anyway, so we need the non-negative part here. So back to this is the first motivation that this study, but the current status, actually, I don't know. I don't know. So, so we try to do the same proof like the Batyrev and original knowledge consorts, but so the main problem is that we don't know what is the dual cone of this one for the on the divisors. I don't know. I couldn't know the. Duals. Dual is and one. Yeah. So maybe so people expect the movable cone, dual of the movable cone, since the dual of movable cone is pseudo effective cone, and dual of pseudo effective curves is net cone. So, and divisor is a limit of the big divisor. So we can do that. We can define some cone using non-ample base locus, and we define some cone, but so I mean that what I said that so we try to understand the dual of this one. So by from the cone divisors. Since and if dual is a net cone. This is grade 1. And NM bar dual is pseudo effective. It's so maybe so once we understand very well for the dual of the NM bar, so maybe so we have some way to describe the concern, but yeah, I have no idea what it is. And on the other hand, we go to from the dual of divisors. So we define the we define the P plus D now. It's a this is non-ample locus. So this is the state of this one. So we consider the intersection of learning the ample divisor and so this is state of this one. So we say that this is non-ample locus. So maybe so people can ask the dual of the NML bar is should be the cone consists of the divisor satisfied B plus D has the dimension less than L. What I want to say that so we consider the sample Lx. X and B plus beta dimension X. So maybe the intuitions with dual is should be the this ample bar X. Since so ample 0 is just amples and the big divisor is satisfied the ample D. So I mistake the some D minus S. So from the point of view this two duality, so we can ask the still for the and then by dual is should be the some describe the divisor by using the this is no. So we can construct the non-equality examples by using the torics by some means. So so from point of view, something so we focus on the dual of this dividers. So this dual should be the not the, we consider that not only that this movable curves. We moving out the Q factory modification. Small Q factory. And consider the bar X. So we actually I should say the first Q factorials. He gave some description of the dual of the some non-ample cones. So and also he proved it the photorics. And later log found case. So maybe the we try to deal the more simultaneously. So it may be possible to use the discon replace with the NN bus. So this discon is bigger than the original motivation cons, but still we have the good description for the duals. So, but still this duality is conjecture. So we need to prove something more. So from here, so we have the only bad news. So we have the a lot of questions and still there are some questions. So now we can say that some good news by the Sonmax. So this conjecture is still open, but we can say the duality is for the Batyrev type cone. I mean the x negative plus amplitude bar. The dual is equal to the e bar x plus right hand side. This is very complicated. So I want to define this cone BNN bar. This is the definition. And BNN bar. B is just bilateral. D minus F. D minus F. So adding the negative part of the effective class, so the desired duality we have. So this is very good news for the concerns. So okay, so now I state the main term that I couldn't, unfortunately, we couldn't prove the full statement for the concept. But we can prove some weak theory. So just we can prove the some description for the concerns, but we just say that so negative part with some local finite extremal race. So R can be spanned by the some numerical proof of the effective divisor. So we don't know that R can be spanned by effective divisor itself. So we can understand the Ri can be, we can understand the Ri by the minimal model program. So we can say, so Ri spans some product of the effective curves. And we don't know the accumulation point of the Ri. Maybe it should be the kx equals 0 part, but still it's unknown. This is okay, so any question? No?
So far, no. So far, okay. Okay.
Okay. Okay, so I will explain the proof structure of the proof of main theorem. So we follow the idea of the proof of the original concept. Firstly, we prove the rationality theorem, some version of rationality. Situation is a bit complicated. So A is amplitude divisors, and such that x plus A is not amplitude. And given the some big divisors, this is Q divisor. In the kx plus A.
Yoshinori, small question. Yeah,
Yes.
can it, from Stefana, can it happen that the Ri may not be spanned by the curves on X?
Oh, I have no example, so I'm not sure.
Okay.
So, well, of course, we couldn't prove that, but I don't have. I'm not so familiar with many examples. So in my stocks, I don't have that. Maybe,
Okay.
but this, maybe have that. Right.
Okay.
Plus ample cons. Sorry, yeah, so yeah, H is just big divisor, but so we can write it down kx plus A plus some still ample divisor. So this ample divisor defined. And so this is ample. I mean that we have the ample L. So kx plus A is outside, and H is inside. So that kind of thing. And maybe you guess that we look at this kind of the scaling of MMP, and we divide this way by scaling again. Anyway, just the intuition. So then there is some open cone in the dividers. Such that first one is the edge should be in the span by ray of the span ray by the kx plus delta plus u, and
Yoshinori,
yes.
before you raise that main theorem, I have a question.
Oh. Yes.
So your Ri, you say is pulled back by some effective curve, but when L is not zero, the effective curve may be in the fundamental locus. So when L is zero, the curve can move, so you don't worry about the pullback. But when L is
yeah, that L equals 0 case is the Batyrev code. We can write that. We can say that R is spanned by the effective curve. But so intermediate one is so some curves intersection with flipped locus or
right
or
inside.
Yes, that's the point here. Yeah, so we cannot say that the pullback with effective.
I see. Okay. Thank you.
Okay, so still we need to write it down or I mean for any H prime, so in the this one, but this is I require the Z divisors. Maybe so you guess that. So original rationality theorem, so we can say the boundedness of the denominators. So maybe I want to describe some version of the theorem of the denominator. So then we need to require the H prime is a G divisor. So maybe sorry, this is A, not A. And of course, so everything can be generalized to the chaotic pairs, but now I just say that for no boundary situation. Plus U. intersection ample L. Then we can set some threshold. We define some threshold for the H prime. It's a threshold for the cone, the ample S. X plus H prime. H prime. Use the H double. So this is the definition of the RL H prime. A. So we said that for H prime, so this RL can be written by the alpha over beta and beta over alpha, and the beta is bounded above. I should say that. It should be depend on the X and A and U. So key point is that beta doesn't depend H primes, just depend the U. So this is our concern, and basically, so once we establish that this is rational theorem, so to go the concern with but by the just similar argument with the original concern. So then so we are thinking that this theorem, the proof of the rationality theorem is the key of the this works. And so then I want to describe the schedule proof of the rationality theorem. We use the finiteness models. So always divisor is big divisors, and ample L is contained in big divisor. So we can use the freely the BCA. And we run MMP frequently. So so we want to use this kind of the effective bounded. So using the MMP, so without finite models, so we cannot control this kind of effective number. But we use the MMP, so appearing the only finite many possibility on the X, depend on X. So we can take some uniform numbers for these models. Then so we can get some effective number. So it's just the intuition. So we estimate that we put maybe that I should say more clear. So take U first is satisfies the and appearing models one many possibility. So it's a we can do that by using the BCSM. And so then for H, we can take the K, so which doesn't depend H prime such that X plus A plus KH is ample. So we can take this case. It's by the length of extreme arrays. So we run MMP for X A plus 1 over R A H. Sorry, this is H prime. So now I should say that R1 is bigger than 1 because this is ample 10. So I mean that 1 minus R K1 is effective. So then we can consider the MMP for this one with scaling over 1 minus R A minus 1. So then we look at MMP. This is the minimum one. So now everything KT in big divisor, we can have the minimum. So, and we have this is scales. So then, firstly, we prove that TI denominator is bounded by induction of I. So I should say, so appearing that this model is finite many possibilities, since every MMP is kind of the Kx plus A plus the divisor in U sum. So we can say that this model is finite many possibilities. So then, to say, so then we can say that the denominator of the TI is bounded from, it does not depend on the models. And so this is just the key, the TI plus 1 minus TI is just so next lecture already knows that that denominator is bounded by the rationality theorems, by original rationality theorem. Then so now we can say the TI the denominator is bounded. And next we need to compare the TI basically Tm minus 1 and the original Rx. So this is also we can say that's always we can prove that RL is bigger than TM minus 1. This is come from the contraction. MMP the contracted model, the contracted rational max. So then we calculated the substitute of the RL and TM minus 1. I mean, RL TM minus 1 is again the sum next threshold. So then I use again the rationality theorem. Then so we can get the original RL denominator found. So this is just the schedule. And yeah, my talk is almost done. So I think the for future to go in the prove something, the accumulation of extreme arrays on this cone. Also, we need some version of the boundedness replaced with the BABs. It's a kind of the relative BA. I hope that by using the theory of complement more effectively, we can establish the statement the accumulation of the RI is going to the kx equals 0. Okay, so maybe I should stop here. Thank you very much.
Yoshinori, thank you very much. Yeah. Is there any questions? Let's wait. Maybe people ask questions. Okay. If you have questions, please ask. Yeah. Okay. Okay. Looks like there are no questions. Yoshinori, thank you very much. Wait, there are questions. Okay, one question is, what's the relation between your ample L cone with Q ample divisors?
Sorry. Would you say
Is any relation between amp L cone with Q ample divisors?
Oh. Oh. Q amples.
Yeah.
Oh, that's it's Q ample. I forget the definition with Q ample. It's just not same as when we take the closure. So Q ample cone is the same as our.
No, I think it's about Q ample means line bundles that sort of kill cohomology in degrees above dimension Q. So like the usual ample would be zero ample. Meaning.
I see. Cohomology because I don't know actually. Sorry, I have never considered that this kind of thing. I can say anything about it. Sorry.
Okay. Zol, did you want to ask some question?
Who, me?
Yeah.
No.
No, because I saw something. Okay, anyway. So. Okay. Wait, it's another question. In the main theorem, your RIs are locally discrete away from k equals 0.
Yes. Because we can prove that. Yes. So we use them. We can prove that. Yes. At least yes. You can say that it's an ample divisor, so sigma x delta is plus h, and the negative extreme arrays. The extreme array of n bar kx plus delta plus bn bar negative extreme array. Negative is kx plus delta plus h. So this is finite set, we can say. So this is coming from the rationality field. So this is, I think this implies the local. Yeah.
Okay. Thank you. Any other questions to Yoshinori? Okay, if no, let's thank Yoshinori again. There's some option in Zoom to clap, and thank you very much. Thank you, Yoshinori, for the first talk at the Zoom algebraic geometry seminar. I think it went perfectly well. The problem was with internet connection on your side, so we need to take that into account. Thank you for a nice talk, and stay safe. Okay, bye. Okay, I'm closing the conference. Thank you. Bye.
Thank you. Bye.
Bye.